I'd like to talk about one important application of finding a tangent line, and it's called local linearity. So we're going to be finding what's called a linear approximation or tangent line approximation. Basically, what it's going to allow you to do is it allows you to approximate the value of a function at a certain point. So I drew a little picture. I have a function f of x, and I have, I'm just going to give you two little things here. I have two tangent lines drawn on there. Basically what this allows you to do, if you're trying to find out, like, let's say that this yellow part is f of a, rather than evaluating that at the specific function, you can often find that value at the tangent line. So this is our approximation of f of a. So we are actually going to evaluate it at our tangent line. By the way, if you have a tangent line that's above the graph, like this one here, your f of a is going to overestimate your actual value. If you had something like this one right here, let's say I was trying to find the f of a here, so that would be, I'll call it f of b just to give a different letter, and then this would be my approximation. If you have a tangent line that's underneath it, that would underestimate. So if you still have no idea what I'm talking about, let's do an example. I think that'll help. So for our example, we are going to find the tangent line to f of x equals 3 plus x at x equals -2. And then we're going to use it to approximate f of -1.9. So for this one, I'm going to tell you right now, if you try to find f of -1.9 without a calculator, it ends up being pretty complicated. You end up getting ln of 1.1. Not an easy thing to evaluate without a calculator, so we're not going to do it that way. We're just going to approximate it using the linear approximation. So we would like to start by finding the equation of the tangent line. I'd like you to pause the video and see if you can find that tangent line. It's stuff that you've done in the past. So first thing you're going to do to find the equation of the tangent line is to take the derivative. Remember that we need to use the chain rule with our ln. Actually, though, the stuff inside our parentheses ends up just being 1. So we get f prime of x equals 1 over 3 plus x. We know that f prime of -2 is going to be 1 over 3 minus 2, which gives us just 1. That's the slope of our line, which is really nice. The next thing that we need to do is find a point on that tangent line. So the point that we're going to find on the tangent line is going to have an x value of -2. To find our y value, we're going to substitute in -2 for our x. We get y equals ln of 1. That is going to be 0. So we know the point -2, 0 is on the line. So if we end up working out this equation, I'm going to go ahead and use point slope form. And you'll find that this one's actually not that bad at all to write in slope intercept form. You should probably simplify this one. We get that our tangent line is y equals x plus 2. So now we can use that to approximate f of -1.9. I do want you to remember that please don't write f of -1.9 equals, because we're not actually finding the actual value, we're finding just an approximation. So we're going to just go ahead and plug that into our equation here. So we just end up getting, it's approximately equal to -1.9 plus 2, which gives us 0.1. You're welcome to try that on your calculator and see what you get. You'll find it's pretty close to the actual value. It's not perfect, but it's fairly close, so it's a good approximation. So one question that we're often asked is this an overestimate or an underestimate? If you know what the graph looks like, it's a lot easier to do it. If you have no idea what the graph looks like, it's a little bit harder, but we will learn some strategies later on to help us out, even if we don't know what the graph looks like. So I'm going to tell you right now, this is not the exact right graph. I'm just drawing a very, very fast sketch, but I'm hoping you kind of get the idea of what it looks like. And the tangent line of this kind of looks like that. Again, not perfect tangent line. I do know that because this line is above it, and you can kind of see that the stuff on the tangent line is above the graph, that this value is going to be an overestimate of my actual values. So that's just something to kind of keep at the back of your mind. We'll do more problems related to overestimate or underestimate later on in the class.